Team Drishti, Eyes in the Sky. Problem statement. AI-based automatic alarm generation and dropping of payload at a particular object through a drone. Imagine an earthquake hits Assam or a flood hits Uttarakhand. In either scenario, death and destruction prevail as far as the eye can see, with no medical aid, food or water in sight, as people cling for dear life, most of them marooned in places beyond ordinary sight or access. Government efforts to alleviate the afflicted take time to dispatch, at least those by road, owing to harsh, unforgivable terrains in these areas. Aid furnished by helicopters also stands inefficient, as SNR teams cannot infallibly find each and every single stranded victim.
Our solution to tackle this is to devise a mechanism that involves transforming the rescue process using drones. The moment calamity strikes, drones carrying a payload will be deployed in the afflicted areas, and on detecting signs of human life anywhere within 50 to 100 meters in the field of view, a payload will be dropped to facilitate the victim's rescue. This, if implemented successfully, will make first response aid far faster, far more efficient, and less prone to human missight than the status quo, saving on travel time and identifying individual victims with greater precision than a human operator. This identification essentially hinges on effective optical and thermal imaging techniques to filter out living organisms and use posterior image processing using Python on a reduced sample space to identify if or not the living being is a human. Further, we aim to detect and identify victims stuck in debris using radar sensing and subsequently generate alerts, ultimately helping to rescue them.
Like any significant technical venture, there will be challenges we need to address. Notably, the accuracy of distinction of humans and other living organisms still stands as a major hurdle to overcome and demands a creative and insightful solution. Furthermore, the range of the thermal camera is called to question, especially given the resolution requirements for successful algorithm deployment on the samples. Of course, there also exist a few interesting minor subsystem tasks. For instance, integrating thermal cameras and radars with Raspberry Pi. But perhaps the greatest obstacle of all is the payload itself, from a load bearing and stabilization point of view. A critical derailing factor in our pursuit would be the cost and availability of high quality thermal cameras, sensors, and radars.
However, having identified these challenges early on, we're confident in our ability to engineer out-of-the-box solutions to each and every design hurdle. With the successful deployment of a drone on the field, we're optimistic about the future of search and rescue, preventing casualties and saving lives.